To help bring all of this together, let's talk about how we're going to design a database and design our tables. That hopefully as we go through this and you start to kind of see how we're going to structure our data, why we need to do it this way, some of the pitfalls if we don't do it this way, that it will start to bring together a lot of the concepts that we mentioned previously. Now, a database is really only going to be as useful as its design. In fact, quite frequently, you're going to find that there are no true right answers, that some implementations may be more useful than others in certain scenarios, but a lot of times database design is more art, is more feel, and a lot less science, that there's not always going to be, this is the way you should do it, period, end of sentence. Maybe certain components, and maybe a certain database, there might only be one way, but more often than not, in a real world scenario, I may not have one clear-cut way to go in and do a design. So it might be a little bit of feel, might be a little bit of art. Or I may actually start making conscious decisions to violate some of the normal rules to help improve the performance of my application. So I may look at my database and go, oh, okay, well, I really should have these two split up. But if I'm constantly joining them together and I, through a little bit of profiling, realize, hey, you know what? That's causing a lot of performance issues. I may decide to go ahead and pre-join that together. Now, one of the things about designing databases is that if you go back and you want to change things, changing a database design, especially one that's been around for a while, can be rather challenging, can cause an awful lot of headaches. So when it comes to database design, this does require forethought. This does require planning. This does require a little bit of back and forth, maybe with the application developer that's going to be using this, maybe the customer for whom I'm putting together this data. There is going to be a lot of forethought, a lot of planning that needs to go into this. Additionally, this does require a fair amount of experience. This does require practice that you will need to develop those skills and be able to kind of figure out, oh, okay, well, this is when I should do this. This is when I should do this. This is maybe when I should avoid doing this. This may be when I should think about doing this. Those types of things do take experience. As a result, designing the database itself is typically going to be done by a database administrator or database developer. So my goal in this section is not necessarily to get real in-depth into database design. That's actually a completely separate course, but really to start to highlight some of the decision-making process. So that way, when you start working with the database that your DBA or database developers handed to you, that you understand why they made some of the decisions that they made. Now, when designing a database, one of the sets of rules that you're going to potentially abide by, or that your DBA or developers abided by, is going to be normalization. And normalization is a process for defining and designing your tables. And you'll notice that normalization takes on 5 separate forms. You can almost kind of think of them as levels, because in order for you to get to, say, third normal form, which is the most common that you're going to hit, you need to make sure that you've met second and first normal form inside of your database.